What are the main sources of data for tracking the Barents Sea temperature anomaly? Have you ever wondered how scientists keep tabs on the temperature changes in the Barents Sea? This area is vital for understanding climate change in the polar regions. Let's break down the main sources of data that help track the Barents Sea temperature anomaly. One of the primary sources is mooring arrays. These are anchored platforms placed throughout the Barents Sea. They come equipped with instruments like conductivity temperature depth sensors and acoustic Doppler current profilers. The conductivity temperature depth sensors measure temperature, salinity, and pressure at various depths. Meanwhile, the acoustic Doppler current profilers track water current speeds and directions. For instance, one mooring located at about 77 degrees 16 minutes north and 24 degrees 24 minutes east has been providing data every 15 minutes. This allows researchers to monitor temperature anomalies and water flow patterns closely. Another important source is long-term mooring arrays that monitor Atlantic water inflow. The Institute of Marine Research has maintained a mooring array across the Barents Sea opening for over 20 years. Since 1998, this array has collected temperature and velocity data. The moorings are spaced about 55 kilometers apart and cover latitudes from approximately 71.5 degrees north to 73.5 degrees north. This long-term data set is essential for studying trends and variability in Atlantic water inflow, which significantly impacts temperature anomalies. Historical oceanographic observations also play a role. Data from research stations in the Barents Sea region provide context for understanding long-term temperature changes. For example, data collected from 1898 to 1993 at specific stations have been used to compute monthly temperature and salinity averages at different depths. These records help scientists identify seasonal and interannual variability patterns, allowing them to distinguish anomalies from natural cycles. Numerical ocean and climate models are another key source of data. These models simulate ocean temperature changes and heat fluxes in the Barents Sea. They use atmospheric data and are validated against observational data. By incorporating surface fields like air temperature, wind, and pressure, these models help interpret observed temperature anomalies. They analyze the processes behind heat transport and the influence of Arctic storms. Model outputs are compared with observational data to assess their accuracy and improve understanding of future temperature trends under climate change scenarios. In practical terms, these data sources help monitor the impact of warming Atlantic water, inflows on sea ice extent, and marine ecosystems. They also improve climate models for the Arctic region and inform navigation and fisheries management in the rapidly changing Barents Sea environment. So, tracking the Barents Sea temperature anomaly relies on a combination of moored instrument data, long-term monitoring arrays, historical oceanographic records, and advanced numerical modeling. Together, these sources provide a clear picture of temperature changes in this sensitive polar region.